Dependent and independent events. What is an event? Well, an event is a set of outcomes of an experiment. So a compound event is one that involves two or more separate events. For example, the probability of passing all 4 exams is a compound event, and that's because you'd have to pass the first exam, the second exam, the third exam, and the fourth exam. So there are 4 different events in that. Rolling a sum of 12 twice in a row. Well, event 1 would be you rolling a sum of 12. And event 2 would be you rolling a sum of 12 again. Or drawing a 4 and a jack from a deck of cards. So first you would draw that 4, and then you would draw a jack. These are compound events. Independent versus dependent events. So compound events are either independent or dependent. Independent means if one event has no effect on the occurrence of another event. A dependent event is if the probability of event B is a direct result of the probability of event A. This is also called conditional probability because there's a condition played on that. So let's try and put that in context and understand what that means. So probability of independent events. Question: you have a 4-color spinner and a standard die. What is the probability of spinning a blue and remember that the word and often means multiply, and rolling a 4 in a single trial. So we're looking for the probability of getting a blue and probability of rolling a 4. Okay, the probability of getting a blue on a 4-color spinner is 1 in 4, and the probability of rolling a 4 with a standard die is 1 in 6, which gives us 1 in 24. 1 in 24 is correct, or you might type this in and see the percent of this as well in your calculator, and that would be 4.2%. So for independent events, the probability of A and B, the answer to figure out the probability is simply taking the probability of the event A times the probability of event B. And it's that quick and that simple. Now what about with the probability of 2 dependent events? So question: you have 4 black and 4 red marbles in a bag. What is the probability of drawing 2 red marbles if you do not replace the first one? Let's get an image here. So you have 4 black marbles in a bag, and you have 4 red marbles in that same bag. What is the probability of drawing 2 red marbles if you do not replace the first one? So event 1 would be you choosing a marble, the first one. So what is the probability you get a red marble? And then the probability that you get another red. So in this type of problem, what we have to acknowledge is that once you draw the first red marble, you'll have less red marbles left in the bag because they are not replaced. So the probability you get a red on your first draw is 4 out of 8 because there were 8 marbles. And the probability that you get another red marble, well, you have to imagine this. Let's make this marble disappear. Now, on the second event, we have 3 red marbles left out of 7. So 4 over 8 times 3 over 7 is equal to 12 over 56, or 3 over 14, which is 21.4%. Okay, the notation for this is the probability of A and B is equal to the probability of A times the probability of B, and this is given that A has happened, okay, or A has occurred. So let's do some quick questions to review this concept. What is the probability of getting a 4 twice in a row with a die? So probability of getting a 4 is 1 over 6. And twice in a row, we're looking for this event to happen twice. So we're looking for the probability of 4 and the probability of another 4, which would be 1 over 6 times 1 over 6, or 1 over 36. What is the probability of getting a jack and then a queen from a deck of cards if the first card is replaced? So the probability of getting a jack and then the probability of getting a queen. The key to this question is the first card is replaced. So the probability of getting a jack is, we have 4 jacks right here. So there are 4 jacks out of the 52 cards. And, which usually indicates multiplying, we have the queens. And there are also 4 queens. If we look down here, so here's our 4 queens. And because the first card was replaced, we have 52 cards remaining. So that gives us a 16 over 2,704 chance, or 1 over 169 if you simplify. So it's quite unlikely that you get a jack and a queen in that order. What's the probability of getting a jack and then a queen from a deck of cards if the first card is not replaced? So here we have the probability of getting a jack, but now we have dependent events because we're looking to get a queen, but we got to remember that a jack was already taken out. So it's given that a jack has been removed. So the probability of a jack is 4 in 52. And the probability that we get a queen, so imagine this, so you get a card, and let's say it happens to be the jack of clubs, that would leave us with 4 queens out of the 51 cards now remaining because 1 is already in your hand. So 4 over 52 times 4 over 51 is 16 over 2,652. Or we can simplify that to 4 over 663. So that concludes the lesson on independent and dependent events.